Assalamu alaikum wa rahmatullahi wa barakatuhu. Welcome you all students for our chemistry lecture chapter number 6, that is chemical kinetics. In our previous lecture we have solved some of the numericals. Today we are going to study integrated rate law for gas phase reaction. Further, we are going to solve a numerical problem based on the same, that is an integrated rate law for gas phase reaction. So here student, for the gas phase reaction, your reactant and product will be in gases in state. A is your reactant, which is gases in state, which get reacted and get converted into the product B and C. The product 2 are in gaseous state. Let initial pressure of A means your reactant, be Pi. The initial pressure of the reactant is Pi. With time, the pressure has been decreases by X within time T. So initially the pressure of the reactant A is Pi, but with increase in temperature as the reaction move further, it get decreases by X. So now the pressure of reactant A at time T will be Pa is equal to Pi minus X. Fine. So the pressure of reactant A at time T will be Pa is equal to Pi minus X. This is our first equation for the integrated rate law for gas phase reaction. Now, as X, the pressure has been decreases by value X. So that much pressure has been found in the product. We are having two different products. So the pressure of the product B and C at time T will be X. Fine. So how much there is decrease in pressure, that much will be the pressure of the product. How much there will be decrease in the pressure of the reactant, that much will be the pressure of the product. So Pb will be equal to Pc, which will be equal to X. Fine. So the total pressure at time T is 10. Total pressure means pressure of the reactant as well as pressure of the product. So P will be equal to Pa plus Pb plus Pc. Fine. The total pressure at time T will be P is equal to Pa plus Pb plus Pc. Substitute the value of Pa, Pb and Pc. Here it has been given directly. Okay. So your total pressure will be equal to Pi minus X plus X plus X. Here minus X and plus X will be cancelled out. Okay. Minus X and plus X will be cancelled out, and what will be remaining behind? Pi plus X. Let us rearrange the equation as we are having P is equal to Pi plus X. Rearranging it, we are getting X is equal to P minus Pi. Fine. What value we are getting? X is equal to P minus Pi. What is our first equation? First equation is equal, here it is Pa is equal to Pi minus X. What is our second equation? Your second equation is X is equal to P minus Pi. Let us substitute what we are going to do further. Pressure of A at time T is obtained by substitution of equation here 6.12 into equation 6.11, that is equation number 2. Value of x we are substituting in first equation. Your first equation is p is equal to pi minus x, and what value x we are getting? We are getting x is equal to p minus pi. We are substituting the value, we are getting pa is equal to pi minus, in the bracket, p minus pi. Open the bracket, we are getting pa is equal to pi minus p plus pi. So pi plus pi, we are getting 2pi, 2pi minus p. As we know, the integrated rate law is k is equal to 2.303 upon t log to the base 10 concentration of A naught upon concentration of AT. Fine, this is our integrated rate law equation. Now the concentration now expressed in term of pressure. Here, as this is the integrated rate law for gas phase reaction, the concentration is expressed in terms of pressure. Thus, A naught will change to Pi and AT will change to PA, which value is 2pi minus p. Fine, A naught will be your Pi and AT will be PA, whose value is 2pi minus p. Let us substitute it in the integrated rate law equation. Then we are getting the equation k is equal to 2.303 upon t log to the base 10 pi upon 2pi minus p. Fine. P is the total pressure of the reaction mixture at time t. Now this equation 6.13 is the integrated rate law equation for gaseous phase reaction. Your k is equal to 2.303 upon t log to the base 10 concentration of A naught upon concentration of AT is the integrated rate law equation. And your equation number 6.13, which is k is equal to 2.303 upon t log to the base 10 pi upon 2pi minus p. This is the equation for integrated rate law for gas phase reaction. Based on this equation, today we are going to solve the numerical. Remember the equation and how we have derived it. So, what is the integrated rate law equation for gas phase reaction? It is k is equal to 2.303 upon t log to the base 10 pi upon 2pi minus p. Let's move forward towards the numerical. Here, problem number 6.10. Following data were obtained. The data has been given during the first order decomposition. Here the reactant has been decomposed. Which reactant? Here the decomposition of SO2Cl2 at the constant volume. Here the volume is constant. Fine. The reaction has been given SO2Cl2. It is in gaseous state. This reactant is being reacted and get converted into SO2 plus Cl2. We are getting two different products. Both the products are in gaseous state. Okay. Now the data has been given at times 0 total pressure. Here it is printing mistake. It is total, not it is total. Pressure per bar at time t0 it is 0.5, but at time 100 second it is 0.6 bar. Okay, I am repeating it again. At time 0 second your total pressure is 0.5 bar, while at time 100 second your total pressure is 0.6 bar. This data has been given in the question. What we are supposed to find out? we are supposed to calculate the rate constant of the reaction. What is rate constant? Rate constant is your K. So as the reaction proceed in gases in state, we are going to apply which law equation? Integrated law, rate law equation for gas phase reaction, which is K is equal to 2.303 upon T log to the base 10 Pi upon 2 Pi minus T. Here Pi, initial pressure, it is being given, it is 0.5 bar and P is 0.6 bar. Time is 100 second. All the value has been given. See in the formula, 2.303 is constant. Time has been given, it is 100 second. Pi has been given, it is 0.5 bar. P has been given, which is 0.6 bar. Let us substitute all the above value, that is the value of Pi, P and T, in the integrated rate law equation for gas phase reaction. So the equation K is equal to 2.303 upon T log to the base 10 Pi upon 2 Pi minus P will change to K is equal to 2.303 upon 100 log to the base 10 0.5 bar upon 2 into 0.5 bar minus 0.6 bar. It is a simple calculation. 2.303 upon 100 will be as it is, log to the base 10 0.5 bar will be as it is, upon 2 into 0.5. What will be it is? 0.5 into 2. We are getting the value 1.0. 1.0 minus 0.6. So if we subtract 0.6 from 1.0, we are getting the value 0.4. Let's solve it. Apply this simple term pi upon 4. If you want to apply log, then we are supposed to do anti-log. It is a simple calculation. We are solving it. Then we are getting the final answer, which is 2.23 into 10 raised to minus 3 per second. In this way, we have calculated the rate constant for the reaction which is in gases in state. It is a simple calculation. Only you are supposed to remember when we are going to apply integrated rate law equation for gases phase, when the reaction carried out in gases phase and the value has been given in pressure, not in concentration. So we are supposed to apply this equation. Hope you all have understood. Till then, study well, do your best. A little bit time has been remaining. If you are having any query, any problem related to the chapter related to chemistry, you can ask us. Hope you all have understood it well. Take care. Thank you, student.